assignment on fatigue and recovery 2.3. So what is fatigue? Fatigue could be if a person is physically or mentally exhausted for a long period. They might be mentally tired. And it's referred to as tiredness, exhaustion, and normally it's physically and mentally. There's three types of fatigue. Local, what example would be maybe when you're doing the 1 rep max, where you'd find your biceps would be feeling quite a sharp pain and soreness, and that would be localized because it's localized to that specific muscle. There's also general, like during a game feeling, maybe in football, the last 10 minutes, you might be getting burning sensation in like maybe your legs or maybe your arms, you're just feeling tired all over. And then chronic is everywhere, every time. So maybe you after that football game or maybe after in a run, you feel just like your legs are tired, and we could say that's just being fatigue. There's many factors what determine fatigue: the intensity you perform at, how long, what type of sport activity you use, the fuel being used. So maybe you're using fats, you're using carbohydrates, fitness levels for that specific person. Maybe if you're, so that would be your lactic acid threshold. So if you've got a high threshold, you'll be able to sustain a higher intensity for a longer period of time. But if you were someone who wasn't so fit, your lactic threshold would be a lot lower, and you'd have to work at a smaller intensity. So you hope to not go over your lactic threshold. And the type of system you're using, hoping that, like, see if it's the how the ATP is getting the P back on. So I'm going to explain how fatigue occurs in um, 4 different examples of intensities. The first one is maximal intensity at very short duration, and I'm using javelin in the example. This is because during this activity, using the ATP system creates a short, sharp burst, as it's really probably max lasts for 3 seconds. So you're definitely using purely the ATP system, and the P is going to be stuck on very quickly because it's not being used again. Because it's a short activity, you're probably using, or you're definitely using the carbohydrates as a fuel of energy. It's anaerobic. So it says because it's anaerobic, you can get a high O2 deficit, and you'll find out what a O2 deficit is in a minute because that's due to recovery. And it's because you don't reach steady state. There's no need to. It's over so quickly. You have neuromuscular recruitment of fast glycolytic motor units because it's quick, sharp movements, and you're very unlikely to be fatigued. Maybe if you're doing javelin short after short after short, you maybe find localized fatigue in your arms. But if you're just doing one throw of a javelin, like this example is, you wouldn't. I'm going to talk about the recovery of this activity later on, but the next activity is moderate intensity and moderate duration. Now I'm using the 400 meters sprint here. So the next activity is moderate intensity and moderate duration, and I chose the 400-meter sprint. 400-meter sprint is a relatively short duration activity, but it's at a very high intensity. The main fuel which you use is carbohydrates, as it's a very high intensity work. And you'd probably use you'd definitely use the ATP to start off with. Then the P will be lost. Then you'll have the PC system, and because the 400 meters is relatively short, you'd probably just be doing the ATP system, and you'd maybe go into the lactic acid system. The PC system will also almost be totally depleted after maximal intensity, and this can contribute to a decline of power output. So once you've done a 400 meter sprint, your legs will be absolutely exhausted and your muscle contractions would not be as powerful as they would normally be. To improve this, to improve your muscles being getting stronger thing, you use something called a PC supplement, and this basically helps us work harder. You still will have fatigue, and fatigue will always occur, but by taking this PC supplement, maybe delays this and helps you have a more powerful muscle contraction for a longer period of time than if you didn't take it. Also, during the 400 meter sprint, more towards the end, you use a lactic acid system, and this is used by using glycogen. So they'll break down glycogen into glucose to pyruvic acid, and unfortunately this leaves the waste gas lactic acid. However, lactic acid isn't always a bad thing because it can be an advantage to us, but as long as it's dealt correctly. So the lactate is basically made of hydrogen ions, and if you deal with the hydrogen ions quickly, it's a good thing, but unfortunately if they're left, that's when problems start to happen. So this is acid in the lactate acid. So basically this interferes with an electrical signals in the muscle nerves and basically slows down the energy reactions, and this means you get the burning feeling in your muscles during exercise because this is a build-up of hydrogen ions. You can reduce this by different ways, by soda loading, what I'll get into in a minute, but also levels of fitness. So if you have a high level of fitness, this means your lactate threshold will be higher. So basically, the fitter you are, the further back your lactate threshold is, but the lower intensity delays the lactate threshold. So at 400 meters, it's a very high intensity exercise, so you're going to reach your lactate threshold very quickly as soon as, because your workload is increased. But these 400 meter sprinters, these athletes, they're going to get used to this burning feeling, so that lactate threshold would be a lot further than what maybe what one of us would be who's not as fit as them. Another way of it is soda loading, and this is basically acts like a buffering system. So this is basically lactate buffering, and it's the removal of lactic acid, which relies on the buffering capacity of the body, which weakens the overall effect of lactic acid. So hydrogen carbonate ion is in the blood, is produced by the kidneys, and it's absorbed by the lactate and forms carbonic acid, and then this allows it to degrade to form CO2 and water, which both can be eliminated via the lungs, and it removes really quickly. So we do this by soda loading, and some athletes will do this to improve their buffering capacity, and this involves drinking sodium bicarbonate several minutes before an event. The benefits of this could be near maximum intensity for a duration of 1 to 7 minutes, and some aerobic events and repeated anaerobic bursts, which might also help this. Because we don't want lactic acid just staying in our muscles, so just this soda loading helps it be removed a lot quicker. And again, this will be improved by a high fitness level and just other analysis of moderate 400 meters would be it's fast glycolytic muscle fibers, and it's a continuous exercise.